Okay, I wanted to do a video on how to find slant asymptotes. A slant asymptote is also called an oblique asymptote. And you've already studied graphs that have vertical asymptotes or horizontal asymptotes, but sometimes we have asymptotes that might do something like this. They might, not be completely vertical or horizontal. Okay, so let's kind of look at this whole problem and look at all the asymptotes in it. But first I'll show you how to find a slant asymptote, and then we'll kind of just do the whole problem just to make sure that you understand how to truly graph this whole thing without having a graphing calculator. All right, if I want to find a slant asymptotes, what I do is I use long division, and I divide the bottom into the top, and if there's any remainder, that's a slant asymptote. Okay, so here we go. Let's try this. Okay, so remember, when we do long division, we say I try to divide x into x squared. Well, x goes into x squared x times, so x times x is x squared, and x plus 1 is, x times 1 is positive x. Okay, so remember, we have to subtract both of these terms here, so it's x squared minus x squared. Well, those cancel out, so I'm just going to go ahead and kind of show that with a green mark. But negative x minus another x is a negative 2x. So we have to keep going, even though you might accidentally just think, oh, there's no left over here. Well, there is. How many times does x go into negative 2x? Well, that would be x times negative 2 would give you negative 2x. Right? Okay, but negative 2 times 1 is, you got to be careful here, negative 2. I'm going to go ahead and put plus 0 up here. All right, so if I subtract negative 2 minus negative 2x would be, those would cancel out, wouldn't they? Because they'd become a negative 2x and a plus 2x. 0 minus minus 2 would be a 2. Okay, so we're going to keep going. I'm going to put plus 0 here because it did not have a constant. Okay, so how many times does x go into 2? It doesn't at all. So I'm going to stop here, and what I have is a remainder of 2. Well, what does that mean, this remainder of 2? Really, do you remember that you can take the 2 and write it over by what you divided by? 2 over x plus 1. Okay, so that's the remainder. But what is the slant asymptote here? The slant asymptote is the result I got when I divided, and you kind of throw away the remainder. Let me write that down. So my slant asymptote is the line y equal this x minus 2 that I circled in yellow. Well, discard the remainder. You just don't pay attention to it, which is nice because it'd be kind of gross to graph anyway, right? So discard the remainder. Okay, so we have a slant asymptote at y equal x minus 2. Okay, didn't realize it was still ticking on me. We're going to do all the rest of this now because this might be something you see on a quiz. Okay, so let's see what we have here. If you remember, if you want to find any vertical asymptotes, you set the denominator equal to 0. So for a vertical asymptote, I would set the denominator x plus 1 equal to 0. So I have a vertical asymptote at x equal negative 1. Okay. So I'll write that down. I'm going to circle all these different things just so you can tell them from the labels in case you get kind of confused. The horizontal asymptote, you remember we used that mnemonic, Bobo Botan eats DC. And bigger, if the exponent's bigger on the bottom, it's 0. We don't have the exponent bigger on the bottom. We have it bigger on the top. So bigger on top is the bot. There is no horizontal asymptote, so we're going to write no horizontal asymptote here. Now the domain, I can plug in anything I want, except if I plug in x is equal to -1, it would make the denominator, I can't have, the things that can't happen is that I can't have the denominator equal to 0, or I have an illegal fraction, don't I? An undefined fraction. So if I look at that, x plus 1 equals 0, x equal -1, my domain is all real numbers, x can't equal, though, -1. And so that would be, let's see, let's take this fraction and let's factor it. The top would be x times x minus 1, and the bottom would be x plus 1. The reason I did that is I want to know x can't be -1. Now, that is either going to be a hole in the graph, or it's going to be a vertical asymptote, and it's a vertical asymptote. It would have been a hole if it had canceled out of the top and the bottom, but it didn't. So if you had this slot on a quiz or something, there are no holes. All right, what about the things like the x and the y-intercept? Well, the x-intercept happened at the 0, so the zeros and the x-intercepts, they're the same things, aren't they? So if you remember, to find our zeros or our x-intercepts, we're going to just take the numerator, which is this x times x minus 1, and we're going to set it equal to 0. Well, if two things multiply to get 0, you can set each factor equal to 0, because one of the two factors has to be 0. So either x equals 0 or x minus 1 equals 0. And that would give us x equal 1 right there. So my zeros are x equals 0, x equal 1, and that's the same thing as my x-intercept, so I'm just going to count it for both. And my y-intercept would be where y is equal to 0. Well, in this case, we already see at x is 0, y is 0. We set y equal to 0 when we set the numerator equal to 0. So it looks like we have a y-intercept just at 0, 0. And that would be answering all these questions there. Remember, for your y-intercept is what happens when x is equal to 0. It's 0, 0. Okay, so that's for the y-intercept, you would, let me just put a little note there, set x equal to 0. Do you remember on your intercepts, you always set the opposite variable equal to 0? We could see the y-intercept because we already had an x-intercept of 0, 0, and so we knew x equals 0 had a y of 0. Anyway, that's how you'd work this problem out if it showed up on a quiz.